Propositional logic. Let's now summarize what we saw about propositional logic in artificial intelligence. Propositional logic is a formal language to describe the world around us that can help an agent model the world. Sentences in propositional logic have a specific syntax with symbols and connectives that can be form logical sentences. Symbols or terms can be either true or false or unknown. Logical connectives are the implication, the conjunction, disjunction, negation, double implication, and we actually like to use connectives to build more complex sentences. It is important to know that syntax and semantics represent two important and distinct aspects in propositional logic, and we have seen the relationship between the two. Semantic represent the configurations or the instantiations of the word with truth values. We saw a very popular word of inference called modus ponens that actually drives new knowledge based on existing knowledge, such as we have P1 up to Pn2. And the conjunction of P1, Pn implies Q, then we can infer Q. This is by what we call modus ponens. Modus ponens deal sometimes with horn clauses when we have the restriction of the form of the clauses that are in the knowledge base. Horn clauses are logical proposition of the form. P1, P2, Pn implies Q. We want some inference algorithm that is both sound and complete. Sound is when we want to infer only true formulas, and ideally complete, and we want to find all true formulas and also specifically the bridge between the two. The inference in propositional logic with horn clauses is sound and complete, and actually so is the resolution rule that we use to do inference. So propositional sounds like a powerful paradigm to represent knowledge about the world in artificial intelligence. However, it has limits. First of all, propositional logic is not expressive enough to describe the world around us, including information about objects and the relationship between objects. It does not, for example, express also time. Also, propositional logic is not compact. In other words, if you want to express that there was a pit in all the rooms in the cave, we have to write that there is a pit in 1 1 or a pit in 1 2, etc., until a pit in 4 4. And you could imagine if you have 10 by 10 rooms in the cave, then we have to do write 10 into 10 100 symbol to represent that. So PL is not compact enough. It cannot express a fact of set of objects without enumerating all of them, which is sometimes very tedious and sometimes impossible. So maybe you are tired, for example, the wampus. I'm going back to pick another example, which is the vacuum cleaner. Which is the vacuum cleaner. So suppose we have a Roomba to clean and 10 by 10 squares in the classroom, and you want to use proposition logic to express information about the squares. But to express that a square is clean, we are going to use a proposition. Square 1 is clean. To express that first square is clean, how can you write that in less heavy way? We are going to express that all the squares in the room are clean as follows. Squares 1 is clean, and square 2 is clean, and square 100 is clean. So that's a little heavy. We have 100 terms, the conjunction of 100 terms. Now, how can we express that some squares in the room are clean? We are going to put a disjunction. Either square 1 is clean, or square 2 is clean, or square 100 is clean. We can also, for example, express that some squares have a chair on, challenge them. In other words, square 1 has a chair, or square 2 has a chair. Also, it's going to become really heavy to express information about all the possible components in the world.